Hi everyone, it is good to be back. I hope you are as excited as I am about doing some math. This is some old review material. It's on logarithms and exponentials. You've done this before. Hopefully most of this is review. Hopefully it's like, oh yeah, I remember doing that, okay. But here's a video just to walk through of how to convert exponential to logarithms, and then you have some practice to do afterwards. First of all, just to recap, exponentials and logarithms are considered inverses, they're opposites. So I just put up some random problems here to do, and basically anytime you have something with exponents, it could be written with the word log, and anytime you have a word log, it could be written as something with exponents. They're opposites. Kind of like multiplying and dividing are opposites, adding and subtracting are opposites. They cancel each other out. As just like an example of what I'm talking about, this is 5 to the x power. If this was 5 times x, then you would be used to like dividing by 5, because 5x divided by 5, you get rid of it. But you can't do that here because x is in the exponent. It's not actually like 5 times x, it's 5 to the x. So instead of dividing by 5 or subtracting 5 to get x by itself, you have to use something called logarithm. What that is to get rid of the base of 5, you make a log base 5. And you do the log base 5 of both sides. Just like if you divide by 5, you cross them out, or you subtract 5, you cross them out, a log base 5 of 5 crosses out, and all you have left is x. Over here, log base 5 of 25 is just literally what you write down. This lesson is just on converting. We're not going to be like solving for x. We're not going to be getting a number answer. It's just rearranging it. It's converting, making it look like something else. So this right here is the answer. The most important thing to note is the base is 5. In every single one of these problems, I'm going to be looking to see what the base is first. So like with number 2, I would say, well, what's the base? Is it the 3, the x, or the 10? And in this case, the base is 3. Since the base is 3, I'll make a log base 3 on both sides. That is how you cancel it. You cancel out the 3 by doing log base 3. So boom, boom, those are gone. And all you have left is x. Log base 3 of 10 is going to be the other side. Just so we're on the same page, this x is a regular x. This 3 is a little 3. It's a subscript 3. That's how it's done with logarithms. A regular log, subscript 3, a regular 10. They're on the same line. Hopefully that makes sense. But anyway, that's the answer. In the next one, what is the base? Boom, boom. The base is x. So as weird as it might be, since the base is x, we're going to make a log base x. Whatever the base is, that needs to match. So the log x cancels the x. And all you have left is a regular 3. And then you write log base x of 19. Log base x of 19. Answer. And finally, same thing, you look to see what the base is. I purposely put x's in different places throughout these questions, but the thing you need to know is that the base is what's important. The base of the exponent is the same thing as the base of the log. They use the same vocabulary word for a reason, not a coincidence. The base of a log has to be the base of the exponent. The base of the log has to be the base of the exponent. Same thing here. The base of the exponent is 7, so the base of the log is 7. Boom, boom, cancel out, and you get log base 7 of x. So taking the log of both sides is what that's called. In the next section, it is what happens if it's a log and you want to make it an exponential. Well, you get to use this really cool word called exponentiating. Exponentiating is basically when you take two sides of an equation and make both of them exponents. Kind of like you can multiply both sides by 3 or something like that. You can exponentiate. It's going to look weird the first time I write it, so the first thing I'm going to do is just kind of over here show you what it is I'm talking about. It's something that should be common sense. So if I said 2 to the x is equal to 2 to the 4th, just for a second. 2 to the x equals 2 to the 4th. Hopefully you could tell me what x is. It should be 4. X equals 4. It should make sense that if 2 to the x is going to be 2 to the 4th, then those two things have to be the same. And that's kind of what we're going to do here. We're saying that if those things are the same, then it's okay to put them inside of exponents together. So like if x equals 3, then I could say, well, if 4 to the x equals 4 to the 3, in either case, you could see that x is going to equal 3. It doesn't matter if the equal sign's there or there. If 4 to the x equals 4 to the 3rd, then x has to be 3. Same thing here. That's what exponentiating is called. In terms of application, once again, the first thing you ask is, what is the base? Log base 3 of 9 equals 2. Log base 3 of 9 equals 2. So the base is 3. And just like before, if this number is 3, we're going to be using a 3 again. And we're going to exponentiate. We're going to put a big 3 on the bottom left and a big 3 on the bottom left. It is important to put it on the bottom left, not on the right, because this is an exponent. What I have just written is 3 to the log base 3 of 9 equals 3 to the 2nd power. That's kind of what I did there. So these two things are now inside of exponents, and they both have a base of 3. But since exponents and logs are opposites, this log 3 cancels that 3, and the only thing you have left is 9. And this says 3 to the squared. 3 squared, not 3 to the squared. And that is the answer. Once again, we are converting. Obviously, 9 does equal 3 squared, but no one cares. We are just converting. On this one, I'll ask again, what is the base? The base is what's matter. What is the base? What is the base? What is the base? Ask that every single time. What is the base? The base is 5. So I'll exponentiate with a 5. Once again, bottom to the left. So 5, log 5 cancels. You end up with 7. And this just says 5 to the x. Feel free to pause the video if you feel like I'm going too fast, or rewind. It's a video, which is awesome. That means you can pause and rewind. So what's the base? 4. Exponentiate with 4. 4 cancels log 4, you end up with x. And this says 4 to the 16th power, which, holy cow, is a huge number. But I don't care because the answer is just that. In this one, what's the question I'm going to ask? Hopefully you just said, what is the base? Because that's up there. And then what is the base? X. So, since the base is x, you create a base of x. And x and log x will cancel, and you end up with 27 equals x to the 3rd. And that is converted. And we're done with that. On the next page, all I have is a couple of practice questions if you want to try them like in the moment. I'm just going to zoom out. And if you want to follow my suggestion, I would pause the video and try them out. So just press the pause, see if you can figure them out, and I'm just going to go over the answers in 3, 2, 1. Okay, let's see how you did. I'm going to use a black pen this time. This is a base 14, so I'm going to create a log base 14 on both sides to cancel that out, and I get x equals log base 14 of 7. On this one, it has a base of 2, so I am going to make a log base 2. Boom, boom. And you get x equals log base 2 of 15. Like that. Here the base is 4. Log base 4. Since that's a 4, I need to exponentiate using a 4, which once again, those cancel, and you get x equals 4 to the 12th. And finally, what is the base? Log base 5. Exponentiate with a 5. Make sure you say the word exponentiate. It will make you happier. Proven fact theorem. Cross those out, you get 125 equals 5 to the third. And that is it. That is converting. These ones were exponential to logarithm. These ones are logarithms to exponentials. I feel like I'll mention something else out. If none of this is making sense to you, there is a different way people do sometimes. I'll do that in blue. It mostly works for these ones down here. Another way you can do it, it's called the heart technique because some people love it. What you do is you start with the bottom here. It's 3, and you go 3 to the second power equals 9, and it draws a big, nice heart. 3 to the second power equals 9. It would look like this. 3 to the second power equals 9, which is exactly what we had here. Over here, if you were to do it, it'd start with the 5. 5 to the x equals 7. 5 to the x equals 7. Don't you love it? It gets you the same answer. It's just a little different. X to the third equals 27. And then here, 4 to the 16 equals x. So I'll put the problems on the back again if you wanted to try that with these bottom two, see if you can get it. It's completely up to you. I'm going to stop the video and let you guys try that practice worksheet. Good luck on it. Take care.